Hello there, today we'll be doing intersection of two arrays using the UMPIRE method. So first of all, we're going to understand the problem. So we're going to take all the numbers from nums1 and find the intersection of between with nums2. So any number that is seen in nums1 and seen in num2 is going to be our output. So our test case would be here. This is our input and this is our output. As you can see, there are 2's in num1 and num2, so we have an output of 2. In example 2 here, what we have is a 4, 9, and 5. As you can see, a 4 and a 9 is available in both arrays. And so we output a 4 and 9. Okay, so what are the minimum number of items that are possible? So the answer to that, 0 to 1,000 different items. And there are 0 to 1,000 the different number items. Okay. So with that, we can have an edge case of let's say nothing inside. So what will we return? We should expect output of nothing, and that should be it, right? Okay, so what is the method to doing this? Method is to using a set. What we plan to do, here's the idea, is that we could just create two sets of nums1 and nums set of num2, and that way we make sure to find if anything is in for every item in nums1, find it in set number 2, or if anything is in number 2, find it in set 1. We could do this by looking at which one's shorter. So whichever has a shorter set of the items, we can use that as our the lookup point, and that would reduce our lookup time because we only have to look up a fewer items. With that, that would be our most ideal solution. Of course, this will take O of n time and n space because we have to create the items in nums1 and create the items in nums2. So it's O of n plus m, m being the length of items in nums2 and n being the length of items in nums1. Also, it will take up O of n plus m as well because we're creating two separate sets to hold all the items. Theoretically, all the items are unique and we will have 1,000 items possible. So this is O of n plus time and space. Okay. With that, there is a way to do this with like a O of n log n time. Well, there's another way where we can do an O of n log n plus m log m time by sorting it and then just iterating through the items, which one's smaller, which one's ever bigger, and we keep moving the two-pointer solution forward. And this would take we'll sacrifice space for time, and basically space would be 1 because we'll be using the same array. So that's the other method. But what we're gonna do here is gonna do the set solution, and let's do the plan. The plan is to just create two sets and find the intersection between the two sets using the shorter set. Okay, so let's implement. Before we implement, there's a very easy way to do this. Let's just do that first. So let's just return set of nums1 dot intersection of set of nums2. This is a way to do this, and it is a very good way of submitting a quick answer. Nums2, there we go. And with that, that is a very easy solution to bring up. Of course, you can see that it is pretty slow when we're taking the longer of the two. A quick way to remedy that is if length nums 1 is greater than length of nums 2, then we'll return return intersection of nums 2 and nums 1. That way we just swap the two, and that would be a way to make this faster. And that was what we were going to do. So this self.intersection, and this is nums2. With that, we can submit this answer. I think it should be quicker. Oh, it's still pretty slow. All right, well, that's the solution. That's our implementation. And we will do a review. And of course, because of their submission, we know it's correct already. But that's exactly as what we planned, and that's exactly the output by creating a set of the two. Let's just go over the code, how it works. So create a set. So the set number 1 is equal to a set of 4, 9, and 5. And nums 2, we create a set, and that's going to be equal to 9, 4, 8. And we compare the equal items, and that would result in a 4 and a 9, or a 9 and a 4. Both ways work. Okay, with the evaluation, we do know that it is O of n time and O of n space due to the creation. And so based on our evaluation, that is the way it looks. Anything else? So I guess you wouldn't want this type of solution. This, of course, allows us to focus on the code at hand, this particular function, because of all the abstracted code away with intersection. But we can focus on that and create a well, this is not the way to do it. This is not exactly what we want to do. It is the set of nums. Okay, so let's clean up this code a little bit. We have still some time. All right, so let's create the set of nums2. All right, run the code. It's still about the same, so it's not much quicker. Okay, so let's create the two sets then. Set 1 equals set of nums1. Set 2 equals set of nums2. And what we're gonna do instead of doing this is return this item. If set 1 is greater than set 2, then set 2, and this is going to intersect with set 1. And here we're going to have set 1 intersect with set 2. Perfect. And let's run it. Submit. Okay, and we can do this instead as well to minimize number of lines of code. And I don't think this makes a difference. Let's submit it. Okay, it does make a difference. because we are looking at the shorter of the two. Okay, with that, we could do it the more proper way. So the proper way is for num in set 1, if num in set 2 output dot append, I think we're returning an array, right? Yeah, a list, append num. So let's create an output, and we're going to return that output. Of course, there's an else statement here, and this time we're doing set 2, set 1. Of course, we're returning the output. All right, so that's the more, I guess, official way of doing this. Of course, we can reduce the lines of code by using intersection. That makes more sense. We could also turn this into a helper function by pulling in the set 1 and set 2. Also, we could just run one line of code, like just this line. So we would reduce the amount of lines of code. It really doesn't. We could just do that instead. Wow, very fast this time. I think it totally depends on what sort of problems that they give our algorithm, and that allows us to get a faster or slower time. Well, with that, we have completed this problem. If you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.